Hello, my dear students and friends. So, welcome to our RSV Physics Class. So, this class is for problem set on dual nature of radiation and matter for your class 12 NEET and JEE course. Okay. So, basically, in this class, typically I will be discussing some problems. So, just read the problem number 1. A beam of cathode ray is subject to cross electric field and magnetic field. The field is adjusted in such that beam is not deflected. The specific charge of the cathode ray is how much? So V is the potential difference between the cathode ray. So you know the cathode ray tube and everything जो है ना आपका जो है photoelectric emission में आपने देखे है ना. So this is types of this the cathode ray tube. Okay. So this is cathode and anode and electron is going. This is on the anode. ओके यहाँ से आपने देखा है अपने लाइट इसके ऊपर लाइट गिरता है ना फोटोइलेक्ट्रिक इफेक्ट में एंड दिस इज कनेक्टेड टू दिस इज नेगेटिव वोल्ट एंड दिस इज connected to positive word and photoelectric current is measured in this device. Okay, so just you see the previous theoretical lecture. Okay, so now this is positive battery, so this is positive and electron is going, so electron stream of electron, basically this is the cathode ray. Okay, so now sometimes it is a beta ray है ना. Okay, now what is it saying? The cathode ray is subject to the cross electric and magnetic field. So somehow electric field is in this direction, electric field, and magnetic field in this direction. This is board plane, magnetic field is in last. See, this is the cross. Just I have seen this is the in your real lecture, the magnetic lectures, you see that if this is means it is coming out in this tip, this is coming outside the board, and it is cross sign means it is going, this the arrow is going, na? This is the arrow, okay. So tip, it is coming outside, and this in the back side of this, it means this one. Okay, so just like so, electric field and cross electric field, matlab electric field in this direction and magnetic field in this direction. So that it is the charge particle is not deflected, means electric Lorentz force due to electric force is E into E, and for magnetic field E V cross B, and V and B, V this direction and B is the sin 90, and sin 90 is 1, so you can write V B. Okay, so electric field equal to E, or somehow you can write V equal to E over this cut gap, E over B. Okay, now the specific charge of the cathode means E by M. This is the ratio, and voltage is the potential, V is the potential difference between cathode. This is the V. Okay, so now see here EV, so it is gaining energy. So from the voltage difference between the two cathode ray, so total voltage gain is EV, electron volt, equal to half m v square, small v. Okay, so how much it is? So E by m equal to E by m equal to जो है आपका half v square by capital V. So equal to how much? V is the E square by B square into V. So half V is the velocity, and it is the voltage difference, E square by B square. This, so specific जो है specific charge of the मतलब E by M ratio. So this is the answer. Problem number 2. The work function of cesium, potassium and sodium are 2.1 eV, 2.30 eV and 2.75 eV. So this is the work function. So you know the Einstein's equation. So of maximum kinetic energy equal to, now I'll read the problem first. If incident electromagnetic radiation has an wavelength of 564 nanometer, then which of the photosensitive surface may emit photoelectron? So maximum kinetic energy of emitted, so this is the surface and electromagnetic radiation is being, so photoelectron emitting from this surface, maximum kinetic energy will be h nu minus work function. So work function is here. So work function, it is pulling the electron. So ये इसको जाने नहीं दे रहे हैं ना. So ये वर्क फंक्शन को क्रॉस करके आपको इतना एनर्जी देना है ताकि ये वर्क फंक्शन के बराबर मिनिमम हो, या वर्क फंक्शन से क्रॉस करना है ताकि इलेक्ट्रॉन बाहर आ सके, है ना. So this is the principle. So this is given by instance. So A phi 0 is basically h nu 0. So nu 0 is your threshold frequency. So particular, after particular crossing the particular frequency, then only electromagnetic radiation is photoelectron is coming. Okay. So that graph you also know. So photoelectron, so particular threshold nu versus photoelectric emission है ना, photoelectric emission. So particular frequency जो nu 0 के बाद ही वो निकलते हैं ना. So it is proportional to जो है आपका proportional to kinetic energy, the photoelectron emission is proportional to so nu, but after certain threshold के बाद ये निकलते हैं ना. So this is the work function. So this is the briefly I have quickly explained the theory. Now work. So it is the surface, and it is the surface of a photoelectric emission, and a electromagnetic radiation is incident on this surface. Okay. So electromagnetic, so it has a wavelength. So see, this is 564 nanometer. Now, so 564 nanometer means how much EV that is required. So in theory class, just theory class एक बार देख लीजिए, उसमें है ना, उसमें that is I have told here energy in EV equal to 1240 over lambda in nanometer, है ना. This is nanometer. So this is the typical relationship with, so how it is coming, E equal to h nu equal to h c by lambda, है ना. h and c का वैल्यू बैठाइए, फिर ये आपको मिल जाएगा हैंडी फॉर्मूला. ओके. सो in EV how much it is, so 1240 over 564 nanometer, it is the order of 2.20 EV. So energy of the incident is so energy is 2.20 EV. 2.20 EV. How much it is, है ना? 2.20. So see here work function of this cesium, potassium and sodium are 2.14 and 2.30. Okay. 2.30. Okay. So now see how much it is. So 2.20 EV radiation is incident on in an energy of this incident radiation. So this is crossing, so energy of this. So ये इसका वर्क फंक्शन है ना. वर्क फंक्शन जो है आपका, सो मिनिमम आपका एनर्जी जो है आपको 2.14. सो इसका जो है सीजियम से वो आराम से निकल सकता है ना. सीजियम का प्लेट से आराम से निकल सकता है, बट सोडियम के केस में क्या है 2.30. सो वर्क फंक्शन इज 2.30 और आपका इंसिडेंट रेडिएशन जो है 2.20 है ना. ये ऑलरेडी नेगेटिव में है, ये निकलेगा ही नहीं. इसका 2.75 सोडियम के केस में, सोडियम से भी नहीं निकलेगा, सिर्फ ओनली सीजियम फ्रॉम सीजियम photoelectric emission will coming out, है ना. So this is the problem. Read problem number 3. When two monochromatic light of frequency nu and nu by 2 are incident on a photoelectric metal, the stopping potential become Vs by 2 and Vs respectively. The threshold frequency of the metal is how much? So this is very much important problem for this chapter, because all the theory and everything is contained inside this problem. So ये आपने कर पाए, so इसका मतलब you understand everything. Okay. So एक problem आपको कहना, this is the core problem of this chapters. Just solve this. So basic Einstein's equation you know, maximum kinetic energy E maximum equal to h nu minus phi 0. Okay, phi 0 or equal to h nu minus h nu 0. This is threshold frequency. So maximum kinetic energy. So you can see maximum kinetic energy, how much it is related. So this is basically stopping potential. So ऐसा एक ट्यूब में आपका ये था ना, यहाँ पे आपका जो है ये आपका यहाँ से लाइट गिर रहा है और यहाँ पे इलेक्ट्रॉन निकाले. सो ये काइनेटिक एनर्जी जो है आपका ये पॉजिटिव है. सो मैक्सिमम काइनेटिक स्टॉपिंग पोटेंशियल क्या होगा आपका, ये वाला प्लेट में, ये वाला प्लेट में अगर इसको वेरी करते हैं, इसमें अगर नेगेटिव वोल्टेज दे, है ना, ये तो पॉजिटिव है, नेगेटिव वोल्टेज देंगे तो ये आपका मैक्स इलेक्ट्रॉन को इधर रिपेल करेगा. सो आफ्टर सम नेगेटिव वोल्ट then no photoelectric current will be detected here. ये एमीटर यहाँ पे रखा हुआ. so this is the system. so आपको एक नेगेटिव बायस देना है ताकि यहाँ का मैक्सिमम काइनेटिक एनर्जी ऑफ दिस emitted photoelectron it will stop. so how it is, you can write, so basically if stopping potential is Vs, so E into Vs equal to h nu minus h nu 0. so this is the stopping potential. So this is the fundamental equation. Okay. Now from here, now you have to solve this. When the photoelectric meter stopping potential is Vs, okay, E into Vs by 2 equal to how much? H nu minus H nu 0. Okay, and E into आपका जो है stopping when incident stopping potential will be Vs equal to how much? h nu by 2 minus h nu 0. ठीक है, जब आपका फ्रीक्वेंसी इतना है तो स्टॉपिंग पोटेंशियल दिस इज Vs by 2 and फ्रीक्वेंसी nu by 2, then stopping potential will be Vs. so subtract it. so this is how much जो है आपका यहाँ से आपको सबट्रैक्ट करने में कितना होगा आपका E into Vs. so basically आपका हाँ, so this is E equal to, so minus E Vs by 2 equal to H nu by 2. okay, so Vs equal to H nu है ना, ये कट गया, minus H nu by E. okay, so now put any of this equation. okay, now how much for this is equation number 1, you put here Vs equal to minus H nu by E. so E into Vs by 2, Vs by 2 means how much? E by 2 minus H nu by E, E कट गया है ना, equal to H nu minus H nu 0 है ना. सो यहाँ पे आपका कितना होगा, आपको जो है H nu 0 equal to, ये उधर चला जाएगा है ना, 3 by 2 H nu. सो nu 0 equal to 3 by, so H कट गया, so nu equal to 3 by nu 0 equal to 3 by 2 nu. so this is the threshold. nu 0 equal to 3 by 2 nu है ना, यहाँ से आपका. so if you solve this problem, then every problem you understand from this. okay, read problem number 4. when light of frequency 2 nu 0, when nu 0 is the threshold frequency of the photoelectric effect, is incident on a metal, the maximum velocity of emitted electron is V1, and when frequency of incident radiation is increased to 5 nu 0, the maximum velocity of emitted electron is V2, the ratio of V1 V2. so this is the metal plate. when incident of radiation is twice nu 0, then emitted electron will be, emitted electron जो है आपका उसका velocity is k maximum जो है ना, this is half m V1 square, and emitted electron, if it is emitted incident radiation is 5 nu 0, then it is kinetic energy will be k maximum is half m V2 square है ना, this is k maximum. okay, So how it is problematic, na? So this is now you can tell maximum kinetic energy half m v1 square is how much? H into twice nu 0 minus threshold frequency is nu 0, means work function is h nu 0. Okay, so this is basically how much? This is h nu 0. Okay, this is equation number 1, and half m v2 square equal to h 5 nu 0 minus h nu 0. So this is 4 nu 0. This is equation number 2. So v1 by divided by 1 divided by 2 equal to v1 square by v2 square equal to 1 upon 4. So v1 is to v2 equal to 1 is to 2. The simple problem. Same equation, Einstein's equation for photoelectric. Okay. Read problem number 5. So these problem are from de Broglie's wavelength and जो है dual nature of radiation. जो so यहाँ पे आपका जो de Broglie's wavelength बेसिकली आपको ये करना है. So यहाँ पे just read the problem number 1. 5 जो है आपका an electron is accelerated from rest through a potential difference v volt. The de Broglie's wavelength of the electron is 1.227 10 to the power minus 2 nanometer, and potential difference is how much? So electron is accelerated from 0 to, this is the voltage V, electron is accelerated, है ना? So its kinetic energy will be EV equal to half m v square. Okay, so this is equal to p square by twice m. I can write na, p square by twice m is half m v square. So p equal to root over of twice m e v. So from de Broglie's hypothesis, every particle has a wave nature as well as its particle nature. So ये जो है p is equal to lambda equal to h by p. So if particles mass is more, then its wavelength is shorter. Okay, जो है आपका अब जो है ये मास इज मोर, तो ये आपका जो है आपका अब नाउ जो है आपका यहाँ से आपको कैलकुलेट करना है लैम्डा इक्वल टू, ओके ना, लैम्डा इक्वल टू हाउ मच? सो लैम्डा, सो नाउ द पोटेंशियल डिफरेंस, सो लैम्डा इक्वल टू नाउ h over root over of p equal to how much? Twice m e v. Okay, so now see here how much it is. So lambda, you know how much? 1.22. so 1 point, so आपको 1.227 into 10 to the power minus 2 nanometer means 10 to the power minus 9 equal to h आपको बैठाना है, h over twice a mass and v आपको यहाँ से आप you can calculate v. So this is the point. So for electron, if someone is asking for de Broglie's wavelength, so basically EV equal to p square by twice m and lambda. So this is the relationship for electron. Okay. Now for photon and neutron, how much it will be? That is the difference. So this types of typical question will be coming for de Broglie's wavelength, है ना? For photon, neutron and electron I have calculated, and for photon energy is how much? Equal to h nu. So equal to h nu. Okay, so equal to, so h nu c over lambda. Okay, so now and p equal to, so p equal to, so आपका so moment and momentum equal to p equal to e equal to pc, है ना? So momentum e equal to जो है आपका half m c. So p equal to, in this case you can write e over c. Problem number 6. The de Broglie wavelength of neutron in thermal equilibrium with heavy water at temperature T and mass m. So in thermal equilibrium, kinetic energy of the neutron, है ना? Okay, this is equal to half c a t. This is the kinetic energy. Okay, thermal थर्मल न्यूट्रॉन जो है ना, थर्मल इक्विलिब्रियम। सो इन दैट कंडीशन, सो यू नो नाउ डी ब्रोगलीज वेवलेंथ जो है आपको क्या करना है, आपको लैम्डा इक्वल टू एच ओवर पी। सो काइनेटिक एनर्जी ई के जो है, और जो ई के ऑफ न्यूट्रॉन इज हाफ एम वी स्क्वायर, दिस इज इक्वल टू पी स्क्वायर ओवर ट्वाइस एम। ओके, सो P इक्वल टू रूट ओवर ऑफ ट्वाइस एम ई, है ना, ट्वाइस एम ए के जो न्यूट्रॉन है ना। और काइनेटिक एनर्जी जो है आपका ई के इक्वल टू हाउ मच, दिस इज इक्वल टू रूट ओवर ऑफ ट्वाइस एम 3/2 के टी। सो ये कट गया, सो रूट ओवर ऑफ 3 एम के टी, है ना। सो नाउ डी ब्रोगलीज वेवलेंथ जो है लैम्डा इक्वल टू एच ओवर रूट ओवर ऑफ 3 एम के टी। ओके, so this is de Broglie's wavelength for thermal neutron. See the situation. Okay, now the problem, if someone is want to know the plot of a P versus जो है P lambda versus P, how much it will be? Lambda versus lambda equal to h over P. So this is will be hyperbola. Okay, क्योंकि lambda P equal to constant. Either it is, if it is, and if this is P and this is lambda, then again it will also, this is a hyperbola. Okay, so this plot you should know. ठीक है, read the problem number 7. An electron of mass m and photon has same energy of E. So photon has a mass 0. Okay, so the ratio of de Broglie's wavelength associated with them. So de Broglie's wavelength, so de Broglie's wavelength associated with the electron is how much, you know? So P square over twice m equal to E, both have energy E, so P equal to root over of twice m E. So de Broglie's wavelength associated with जो है ये electron is lambda equal to h by P. So h over P is root over of twice m E. But for photon, how much P? For photon बताइए। So हमने इलेक्ट्रॉन, न्यूट्रॉन एंड फोटोन के लिए de Broglie's wavelength कैलकुलेट किए। So एक ना एक प्रॉब्लम इट विल बी कम इन योर एग्जाम, है ना, जस्ट एंड प्लीज क्लियर योर कॉन्सेप्ट है। ओके, सो फोटोन एनर्जी इज E equal to PC momentum, so P equal to E over C. So de Broglie's wavelength of photon equal to h over जो है E over C, so hc over E. ओके, सो जो है आपका h, सो लैम्डा E over लैम्डा P इक्वल टू जो है h over रूट ओवर ऑफ ट्वाइस m E, एंड नीचे क्या है आपका h c over E. सो दिस इज द रेशियो। सो ये आप एक बार ये कैलकुलेट कर लीजिए, है ना, ठीक है। सो ये दिस इज द, सो फोटोन के लिए ये आपका यहाँ से आएगा आपका। सो रिलेटिविस्टिक मास को आप इसमें जो है आप बाद में सीखोगे, स्क्वायर इक्वल टू P स्क्वायर C स्क्वायर प्लस m0 स्क्वायर C टू द पावर 4। when इस एनर्जी इज हाउ मच, सो रेस्ट मास एनर्जी इसको नेग्लेक्ट कर सकते हो, सो E इक्वल टू ऑफ द E इक्वल टू PC देख सकते हो। ओके, है ना। सो और जब काइनेटिक एनर्जी जब बहुत ज्यादा है फोटोन के केस में जो है, सो वो आपका यहाँ पे सुनाओ इसमें जो है फोटोन के केस में इक्वल टू पीसी की रेस्ट मास इज 0 हियर, है ना। सो नाउ दिस इज द टिपिकल 7 प्रॉब्लम आई हैव डिस्कस्ड फ्रॉम दैट इज ड्यूअल नेचर ऑफ रेडिएशन एंड मैटर। सो आपको इस टाइप का डिफरेंट टाइप्स ऑफ प्रॉब्लम सॉल्व करते आना चाहिए, and see that this is a typical problem and you will get common from this 7 questions. This is very much important. So repeatedly see the problem and practice it. How much you are practicing, that is important. Okay, so your speed in your exam it will increase and you will obviously succeed in your exam. Okay, thank you.